Hi everyone. So in this video, I will try to cover the next material definition. This is for the um, other in the material, and it is bounding came clay. Right. So let's name it with. So without wasting any further time, let's define the density and then upside axial ratio and bulk modulus and all those stuffs I will write from this already developed material um, for the Borja et al. Element material. So these are the input parameters. So I will use these already available parameter and then I will discuss them. So um, these are about the failure criteria of the material and its mode of failure. So let's just discuss them one by one with what is happening in the matter. So this first one material that is the mass density, it is the mass density of the soil, and then here come the left side axis ratio, and this is basically defining the shape of the left side loading and bonding surfaces here. So let's say we have this material for the soil and we have this failure criteria, right? So it's failure surface and we have this Moore Coulomb criteria. So and we have this excess ratio. So for that, the excess ratio is the definition of the stresses here. So if it is one here, it means that the shape is a circular shape. If it is less than one, it is an ellipsoidal shape here. So this is for the loading and unloading condition, and we have the definition for the bulk modulus of the material, which is obvious, and it can be obtained from the mass density, right? Then we have this OCR that we defined here. It is given here, the work consolidation ratio, and we have this other parameter, this is OCR, and this OCR, it represents the overconsolidation ratio, which defines the relationship between the loading surface and the bonding surfaces. And we don't need to memorize them. We just need to get them when we require these values. MU, this parameter indicates the initial shear modulus of the material, and we have this alpha, which represents the pressure dependency parameter for the moduli, and we have this other parameter lambda, and this lambda describes the soil compressibility index for version loading, and then we have H. So H represents the hardening parameter for the plastic response inside the bonding surface, and then we have the M parameter, which denotes the hardening parameters for plastic response inside the bonding surfaces. So the given code that we discussed here defines the parameter for bonding clay material model, which can be utilized with engineering simulation to analyze the behavior of material subjected to different loading conditions, and it's good for accurate site modeling and for the versatile simulation, for the soil behavior decision making and research and development and risk mitigation. So I just use these material, but the thing is we can use this for the soil model and we can utilize it. So after that we have other material definitions, and those materials are okay, plasticity. So I will discuss them in the next video.